Welcome to Roadmap to Residency. Hello everyone, I am Aviraj. Welcome to our Club 250 Matchmaker sessions. We will be running through a question with you guys to help you on our journey to 250. So we have, which of the following substances is most likely reduced in this patient? So we have a 25-year-old man who comes to the physician because he and his wife have been having difficulty to conceive for the last 2 years. They have no children. Infertility evaluation is begun and the lab study shows a low sperm count. A more thorough evaluation elucidates a rare genetic abnormality that leads to permanently inactive FSH receptors. Which of the following substances is most likely reduced in this patient? FSH, LH, inhibin B, testosterone, or DHEA? We will come back to the question, but let's first discuss about gonadotropin regulation. So here we have when the hypothalamus secretes the gonadotropin releasing hormone, this acts on the anterior pituitary, and then the anterior pituitary secretes the FSH and LH. Now, when the FSH and LH are secreted, the follicle stimulating hormone acts on the Sertoli cells, and the Sertoli cells then release the inhibin B. Okay, the luteinizing hormone acts on the Leydig cells. So the L for L, luteinizing hormone, Leydig cells, and Leydig cells secrete the testosterone. Now, I like to use this opportunity to also discuss about the negative feedback loop in the gonadotropin regulation. So when the inhibin B is secreted, then this inhibin B will have a negative feedback on the anterior pituitary, and that will lead to the decrease in the FSH beta subunit. When there is increased testosterone, then that will have a negative feedback on the hypothalamus as well as the anterior pituitary, and that will lead to decrease in the gonadotropin hormones release and decrease in the LH release. So our patient has decreased concentration or decreased level of inhibin B. It is because the pulsatile secretion of gonadotropin releasing hormone from the hypothalamus stimulates a release of follicle stimulating hormone and luteinizing hormone from the anterior pituitary. The LH stimulates the release of testosterone from the Leydig cells, and FSH stimulates the inhibin B from the Sertoli cells. The testosterone and inhibin B induce negative feedback. We all know that by now. Now, this androgen binding protein, now the Sertoli cells also produce androgen binding protein locally. Now, this androgen binding protein is responsible for the high local testosterone concentration and is different from the sex hormone binding globulin, which is found in the blood. Now, the high local level of testosterone and FSH are necessary for spermatogenesis. The defective FSH receptors will lead to decrease in the spermatogenesis and cause low inhibin B levels. Now, FSH is responsible for both spermatogenesis and inhibin B production. So, our patient has defective FSH receptors, due to which the FSH cannot act on the Sertoli cells, and due to which there will be decrease in the inhibin B levels. So let's discuss about the other hormones mechanism too. So here we have the growth hormone. So when there is the patient sleeps well, like in case of child, we advise the child to sleep well because sleep induces the growth hormone releasing hormone secretion. So sleep, hypoglycemia, stress, puberty, and exercise releases stimulates the growth hormone releasing hormone secretion, and aging, obesity, and hyperglycemia inhibits it. Okay. Now the growth hormone releasing hormone acts on the anterior pituitary, and then it releases the growth hormone. Now this growth hormone acts on the liver, and now the liver produces IGF-1, that is insulin-like growth factor. Okay, it is a growth factor, growth hormone derivative. Insulin-like growth factor 1, which acts on the muscle and the bone. In muscle, it will cause increased amino acid uptake and increase protein synthesis. So it will lead to increase in the muscle bulk. In the bones, it will lead to increased DNA RNA synthesis, increased collagen, and increased cell size and number. So it will lead to stronger bones. Also, the growth hormone directly acts on the uh, adipocytes, and it will lead to decreased glucose uptake and increased lipolysis. So when there's decreased glucose uptake by the adipocytes, there will be increase in the blood sugar. So growth hormone is a diabetogenic hormone. Now let's talk about the prolactin. Okay. Now, whenever there is a slight sight or a cry of the baby, then that will stimulate the higher cortical centers. Okay. Now the higher cortical centers will then uh, inhibit the hypothalamus. Okay. Now the hypothalamus secretes the dopamine and TRH. Now dopamine inhibits the anterior pituitary. You know that, okay? Now, when the dopamine inhibits the anterior pituitary, prolactin is not secreted. But when there is stimulation in the higher cortical secretion, higher cortical centers, hypothalamus is inhibited. Now, when the hypothalamus is inhibited, dopamine is not secreted. When the dopamine is not secreted, then that will stimulate the anterior pituitary, or that will not inhibit the prolactin production. Also, the prolactin production is influenced by the TRH that is secreted by the hypothalamus. So higher cortical center acts on hypothalamus in two ways. That is, it will decrease the dopamine and it will increase the TRH. Okay, sorry. Now the dopamine's inhibitory action on prolactin production is lost. The TRH stimulatory action on the prolactin production is increased. So there will be production of prolactin. Also, uh, in case of pregnancy, there is excess estrogen. Now, estrogen will also stimulate the prolactin production. In case of renal failure, there will be decreased prolactin elimination. So also there will be increased prolactin in that case too. Also, uh, prolactin itself will have a negative feedback loop. Now, when the prolactin is excess, then it will actually stimulate the hypothalamus to produce dopamine. Okay, and this dopamine will inhibit the anterior pituitary to secrete the prolactin. Okay, also some of the medications like just wall some medications like the psychiatric medication, okay, antipsychotics, then and also the chest wall injury and also the nipple stimulation, this will inhibit the dopamine production. And also the in case of primary and secondary hypothyroidism, there will be increase in the TRH, okay, and this TRH will consequently lead to the increase in the prolactin. Now this prolactin will also inhibit the GnRH, and GnRH will lead to the FSH and LH, right, stimulation, and there will be ovulation or spermatogenesis. Now when the prolactin inhibits the GnRH, then the ovulation is inhibited. Okay, there will be hormonal contraception. Okay, there will be physiological contraception, and this prolactin will cause the milk production. Now let's talk about the cortisol action. So the stress circadian rhythm, hypothalamus. So the stress circadian rhythm will just stimulate the hypothalamus to release the corticotropin releasing hormone that will act on the anterior pituitary, and the anterior pituitary will just convert the pro-melanocortin into the endorphins, melanocyte stimulating hormone, and ACTH. That's why when there is increase in the cortisol production, then that will ultimately lead to the increase in the melanocytes that will increase in the uh, darkness of the skin. Okay, now the ECTS produced by the anterior pituitary will then act on the will act on the adrenal gland to produce the cortisol. Now this cortisol will itself have a negative feedback loop on the anterior pituitary and the hypothalamus to control its level. I would say, so next one we have internal and external stimuli. So this is just a summary of all the feedback loops, all the hypothalamic pituitary axis. Then we have internal and external stimuli, neurotransmitters, hypothalamus. So the internal stimuli will just secrete the neurotransmitters, and that will stimulate the hypothalamus. Okay. Now the hypothalamus will release the ADH and oxytocin that will travel through the nerve tracts. Now this is the posterior, and this is the anterior. Okay. Now the posterior hypothalamus, or the posterior pituitary, sorry, posterior pituitary will then secrete the antidiuretic hormone which acts on the kidney. Oxytocin acts on the breast and the uterus. And then we have the anterior pituitary hormones, which is prolactin acting on the breast, FSH and LH acting on the ovary, testes. We have TSH acting on the thyroid gland. We have ECTS acting on the adrenal gland. Growth hormone acting on the bone and muscles. Okay, and then there is the negative feedback loops of the adrenocorticosteroids, thyroid, testosterone, estrogen that will inhibit the anterior pituitary and the hypothalamus itself. So this is just a hypothalamic pituitary and uh, gland axis, and also the negative feedback loop summary. Now, another important topic for today is the hormone signaling pathways. So there are typically two hormones, protein hormones and steroid hormones. So talking about the protein hormones, so the non-steroid hormone or protein hormone, they just act on the receptor protein, okay? They just act on the receptor on the plasma membrane of the target cell. That will lead to a chain of reactions, and that will lead to conversion of ATP to CAMP, okay, cyclic adenosine monophosphate. And this CAMP is the second messenger. And then the CAMP will act on cellular functions such as glycogen breakdown and all, okay? This is just a simple mechanism of protein hormones. Now, what is important for us is the steroid hormones. So whenever the steroid hormone binds on the receptor in the cytoplasm, okay, binds on the cytoplasmic receptors, steroid hormones are lipophilic, and therefore most circulate bound to specific binding globulins which increase their solubility. Okay, now they bind on the cytoplasmic hormones, and there is the transformation of receptor to expose the DNA binding protein, and then this will just migrate. Okay, now this complex will migrate in the nucleus, and then there will be binding of the enhancer like element in the DNA. And when it binds on the DNA, then there will be the uh, uh, biochemical mechanisms, okay, transcription, translation occurring, and that will lead to the formation of the uh, response or formation of the mRNA or mRNA signaling or formation of mRNA that will produce the response. Okay, mRNA then will produce a protein, and this protein will produce a response. Okay. Now, talking about other signaling pathways like CAMP. So CAMP is the signaling pathway for FSH, LH, ACTH, TSH, CRH, HCG, and ADH. CGMP will be the signaling pathway for BNP, ANP, okay? And also we have inositol triphosphate which will be for the GnRS, oxytocin, ADS, and all. And there will be intracellular receptor will be available for progesterone, estrogen. Now this one is typically very, very important. Let me just highlight this. So on this slide, you need to know about what are the intracellular receptors available for which hormones. So progesterone, estrogen, testosterone, and there will be so intracellular receptors are lipophilic receptors, okay? So, and also there will be receptor tyrosine kinase, which will be uh, um, responsible for the IGF-1, PDGF, EGF, insulin, okay? It is also very, very important concept. And also there are some serine threonine kinase receptor, which will be important for the TGF beta. So I hope you like the video. We will again back in the next one with the super duper concept. Thank you for watching.